in order to write the net equation for a sequence of reactions, the steps you need to take are that you have to realize that the reactants on the left-hand side of the reaction arrow for step 1 and for step 2, you will add together to be the reactants in the overall balanced equation. And the same for the products in step 1 and step 2, you're going to add those together and they will be the products in the overall balanced equation. And just like any kind of mathematical equation, if you get like terms, like if you have 2x on the same side of the equation twice, you have 4x on the left-hand side of the equation, for example. If you have the same element or compound in the same state of matter that appear on the same side of the equation, you can add them together. Likewise, if they are on the opposite side of the equal sign, if you had 2x equals 2x, right, those would cancel out in a mathematical equation. And the same thing here, if you have the same element or compound, usually it would be a compound, right, unless it's just like a standalone element for whatever reasons. The same compound on both sides of the reaction arrow, the same quantity, the same state symbol, it's going to cancel out two like terms on opposite sides of the equal sign in a mathematical equation. So in a chemical equation, this would be called the intermediate, which is a species that is formed at the end of one step, and then it gets used in a subsequent step. So the key to balancing then is to find the intermediate, and you will have to multiply one or both of the reaction steps by some integer so that the intermediate will cancel out. So in this equation, I can see that the intermediate is going to be manganese 4 oxide because it is made at the end of step 1 and it gets used up at the beginning of step 2. However, at the end of step 1, we've made 2 moles of magnesium 4 oxide, and we require 3 moles of magnesium 4 oxide to make step 2 progress. So the key is working out what integer is going to make that intermediate cancel. Now, this is actually a tricky one for a first example because we're going to have to multiply step 1 by 3, which means every species in step 1 gets multiplied by 3, and step 2 by 2, because lowest common multiple of 2 and 3 will be 6, right? So I want that manganese 4 oxide to cancel out. So sometimes it's actually easier to rewrite the equation to make sure that you have multiplied everything by 3. So 2 manganese, 2 carbonate, well, 2 times 3 is going to be 6 manganese carbonate. And I'm going to be naughty and leave off the state symbols, or we'll be here all day, but really you should keep the state symbols on, because if you're cancelling anything or gathering anything together, it does need to be the same state of matter. 2 plus 2, 4, 6 carbon dioxide. So that's step 1, and then step 2, going to times everything by 2, so 6 MnO2, 4 times 2, oh, the 8. So just make sure you don't forget anything, okay? I'm going to make this line up a little bit better, just so. There we go. And then 3 times 2 will be 6. More coffee required. And then 2 times 2 will be 4, Al2O3. So then what we're going to do is we're going to add them together. So anything on the left-hand side of that reaction arrow is going to be a reactant in the overall equation. Anything on the right-hand side is going to be a product. So overall, we've got 6 manganese 2 carbonate, it's too early for this, plus 3 O2, plus I did do my live Q&A at the usual time yesterday, but unfortunately I sneezed and pressed the mute button on my headset and then forgot to unmute myself, so the entire recording is busted. So that's all my reactants and all my products: 6 MnO2 plus 6 CO2 plus 6 Mn plus 4 Al2O3. So hopefully you guys can see that, you know what, I'm going to do a little cheeky copy paste here, because what I'm going to do is show you how that intermediate then is going to cancel out, because I've got manganese 4 oxide on both sides, so that's going to cancel out. So that will leave me with, please say this works. No, I forgot I use a PC at work and a Mac at home, and I pressed Control instead of Command on my Mac. And look where we are now, I'm typing. So that went well, didn't it? So this will be our overall balanced equation. If you're not sure if you've done it right, what can you do? You can do your bookkeeping, right? So you can count up how many manganeses, carbons, oxygens, and aluminiums you have on each side of the chemical equation. And I think you will find that that is beautifully balanced. So that was a tricky one because we had to multiply both steps by an integer. I wish I got that one second, but that's the way the cookie crumbles. Okay, so for this one then, let's see if we can work out what our intermediate is. So for this one, our intermediate is going to be the diphosphorus pentoxide. So look at that one here. It's formed at the end of step 1 and gets used up at the beginning of step 2. So hopefully you guys can see that we just have to multiply step 2 by an integer. If we multiply it by 2, then everything will cancel. So I guess we should go ahead and do that. So step 1 is going to remain unchanged. Okay, step 2, if you like, you can just go in and put the 2's in. So 2P2O5, 3 H2O's times 2 is going to be 6 waters. Okay, it's going to change 2. So I'm going to change my coefficient to 6. And then 2 times 2 will be 4. So 2 diphosphorus pentoxide plus 6 waters goes to 4 phosphoric acid. So let's add those 2 steps together. So overall, what do we have? We have P4 liquid plus 5 O2 gas. I should be putting these in really. I'm very naughty not putting them in. And then we have 6 H2O. Notice that when you sort of get a bit more practice at these, you don't have to rewrite both steps unless it becomes very messy. Okay, I've already cancelled the intermediate because I can see that it cancels out. And then I have my product just for H3PO4 liquid. Cool. Would have thought it would be aqueous. Okay, so that would be my overall balanced equation.